Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 13 of the December daily Leetcode challenge. We are almost in the middle of this challenge, that is December daily Leetcode challenge, and we again have a medium question in front of us. Let's see what this question is. I felt this is slightly on the easier side, especially if you know see, it's all about sorting basically. If you know sorting, still you can solve it. And there's also one data structure to which this question is targeting. We'll talk about that as well. But yeah, this question is slightly on the easier side. Even with simple brute force approach, you will be able to solve it. But yeah, it has to you cannot be everything cannot be brute force. Some part of it, some segment of it has to be optimal. Then yeah, you can use the brute force idea, but yeah, it has to be implemented optimally. That's what I want to say. Yeah. So coming to this question, it is 2593. Find score of an array after marking all elements. Okay. So basically, if you see, this is what is given to you. A numbers array is given to you, and yeah, that is it. That is the only thing given to you, and you have written an integer as the output. Okay. So what they are saying is, you are given an array nums consisting of only positive integers, starting with score of 0. Apply the following operations. So these are some of the operations that they're trying to, they're asking us to apply. Let's see what they are. Choose the smallest integer of the array that is not marked. Okay, there is something called as marking. Okay, we'll come to that what it means. But for now, just understand that there is something called marking. If a number is marked, we cannot select it. That's what they're trying to tell. Choose the smallest integer of the array that is not marked. If there is a tie, choose the one with the smallest index. Remember, once you see this, I am sure that if you are a pro coder, that is at least if you are an experienced coder, you will be able to understand after seeing this what is that it is that you have to apply. Okay, what is the algorithm that you're trying to apply? Okay, because many data structure will not support these kind of things. Okay, smallest index and all these things should be popped first, and these things will not be supported by many data structures. Okay, so please be attentive to these details because this will be mattering a lot basically, especially in online assessment. When you submit, you will get to know that your code is not getting accepted. Some of the tests are failing. Why they are failing, you will not be able to see the output and all those things. So in that case, these things will play a small, very important role. That is small, that if two values are smaller, that is if two values are same, the smallest index should be popped first. Okay, those things will not be supported by every data structure, so remember this thing. Choose the smallest integer of the array that is not marked, and yeah, then the other one I explained already. Add the value of the chosen integer to score. So see, the idea here is, once I choose the smallest integer, okay, that I am going to take and add it to my score, any existing score. Okay, initially when I start the program, it will be 0. After that, I will keep picking the smallest one which is not marked, and I will be adding that to my score. Okay, similar that. Mark the chosen element and its adjacent elements if they exist. Okay, what they're trying to say is, see, this is what I was marking. See, we previously learned about what is marking, right? See, that is they're using marking, but currently we are going to get the definition of the marking. So what they're saying, the current element that you have chosen and the two adjacent element, that is the one to the left of it and one to the right of it. Okay, exact left and exact right. Okay, immediate left and immediate right, that we'll have to mark. That is, they should not be selected in any other iteration. Okay, that is what they're trying to say. Mark the chosen elements and its two adjacent elements if they exist. Repeat until all the elements are marked. So you have to repeat this until all the elements are marked. Return the score you get after applying the above operation. Okay, so let us quickly try to see what they're doing in example number one. So see, example number one, if you see, the smallest element is going to be 1 here. Okay, there is no doubt that it's going to be 1. And one more important thing is, see, the number 2 is present 2 times. Okay, with different indices obviously. So this particular 2 and this particular 2. Okay, so obviously, if at all you have to select a 2, this should be selected first and not this one. Okay, that is what they were trying to tell. But in this case, I guess will not come. Let's see this now. See, first, the smallest number is 1 and it's written only once, so it is very clear what we have to select. Okay, take that one, add it to our answer. So what is our current score is going to be? Score is going to 0 plus 1. Okay, fine. If you see the adjacent element, that is now 2 and 3 will also be marked because they are adjacent to the element that we have chosen. So 2 and 3 are out of our race now. Okay, so this will not be considered now. Next, among the remaining elements, these are the remaining elements, which is the smallest. There is a single 2 in the remaining elements which is smallest. Okay, so the all those concept of selecting the smallest index if they have same value, all things are not applicable here. Okay, so I'm just selecting the 2 among the, see, these are the remaining elements. 4, 5 and 2 are the remaining elements. Out of them, 2 is the smallest. I will select 2. Okay, and I will mark its adjacent element also. And what marking means is that the adjacent element, which is 5 in this case, will not be selected after that. Okay, so 5 is also marked. The only remaining integer is 4, so we'll just select 4 because already all the adjacent elements of 4 are marked, so don't have to do anything much. So what are the elements that we selected? First we selected 1, then we selected this particular 2, and we selected this particular 4. So the answer is going to be this thing, 1 plus 2 plus 4, which is 7. Okay, 7 you have written as the answer. Fine. Coming to example number 2, you can see, go through it. See, again here the same case, 1 is present. Take 1. Once you take 1, these are the ones which will be marked. Okay, as you can see here, these are the ones which will be marked. Now, among the remaining, you can see that there are two 2's present. Okay, there are two twos present. Out of them, which one you have to select? You will have to select the one which has the smallest index. That is, you have to select this one. If you select this one, what will happen? See, now these are all marked. Okay. Then there's another two left. So now you have to select that two. So the answer is going to be 1 plus 2 plus 2, which is 5. Okay. If you see the constraints are pretty much the same what we see in any medium level question. Okay. There is nothing new in this. Okay. Let us come to the solution. See, there are two kind of solutions possible. You might have, as I mentioned, if whenever you see the indexes, okay, whenever you are dealing with indexes, it's always better because see, just try to understand what is happening here. The first question that will come to my mind is whether the sorting is going to help me or not. See, first thing you will think of is sorting, but we'll have to understand whether sorting is really going to help you or not. Because see, if you just need the smallest element in each iteration, so you, as we saw, last yesterday's video also, sorting is not the ideal thing in that case. Okay, why? Because we only need the smallest. We don't need the second smallest or something like that. Okay, but in this case, just see here, we you know there is no such limitation that we only need the first smallest or something like that. Okay, the idea here is once you sort it, it will be useful even after that. Okay, that is the basic idea, because every iteration we keep getting the smallest one, and if they are marked, we have to simply discard them and you have to keep using them. So I guess sorting is the right way here for this question. Let us see how. As you can see, first I have taken a set. This set will help me like which all indexes are marked. Okay, there has to be some way, some logic for me to identify, right, which all indexes are marked. So I will be using this will tell me which index is marked. So I will be showing the indexes here. Those indexes can be considered to be marked. Okay, marked element index, as simple as that. Then I'm capturing the length. Then I am going to design the input array. Okay, I'm giving the name as input, but we can give some valid proper name here. I'm just giving it for your reference, as simple as that. So in this, see, one thing is very clear. It's not just the number but also its index. Okay, you will have to understand this point very clearly, because as we have clearly mentioned, if two numbers are same, they have to you have to consider the smallest index first. Okay, so for that reason, I will be storing this. This is going to be a single element in the input array. So what this element has? This element has two parts. First one is the number itself. The second one is the index. Why I have kept the number first? Because always remember, especially if you're using heap and other data structures, only the number which is present in the first will be sorted. Okay, the sorting will happen only based on the zeroth index of the element. That is, if this is element, the sorting will always happen based on this. Okay, if you are using a table data structure, but in Python that is not like that. Okay, for example, if you're doing this dot sort, so this sort will also consider these elements, that is the second element, third element, and so on. Like these things will be considered, so I don't have to pass a key here. Basically, see, normally what you can do is in Python is you can pass a key basically. Okay, key, yeah, basically you can just pass a key which is a lambda function, and you can do that. Okay, and you can keep doing that. Okay, as similar that you can write x of 0 and you can write x of 1 and so on basically. Okay, you can, yeah, keep doing that. That is up to you. But yeah, what I just wanted to tell you is that, see, that is not needed here, because when we are using sort, the beauty of Python is that it will already consider like this also. And once, if let us say if you have two elements for which the zeroth index is same, then it will sort based on this particular index. So it will ensure that the number which is, if the two numbers are having same value, it will sort based on the index. Okay, simple as that. So basically we do not need this particular part here currently. Okay, it is not needed. It's already taken care, as simple as that. So I'm doing the sort. Remember, the sort is ensuring that the number which has the smallest index will come first. Okay, as simple as that. Next, I'm creating a score, and then basically I am going through my elements. Okay, then I'm going through each of this element. Okay, in each element there are two parts. First is the element itself, the other one is the index. Okay, there is a number itself and the index. Okay, so first I am checking for each iteration whether the index is not marked. If the index is not marked, only then I will proceed. Okay, as simple as that. If it is not marked, I will take the element value element part of it and add it to my score. And for the index plus one and the index minus one, if they are in the range, if they are in the current range, that is 0 to n minus 1, if they are in that range, I will add them to my marked set. One question that you will ask is me is that, see, mark the chosen element and its two adjacent elements if they exist. See, this part we are doing, two adjacent elements already we are doing, but I am not doing this part. That is, I am not marking the index that I've already visited. That is, if you see, I am, what are the things that I'm adding to my marked element index? I'm adding index plus one, I'm adding index minus one. But where is it that I'm adding index? So the idea here is, see, once the index comes, it will not come again. So okay, that is the basic logic. So for example, this index came, there will not be any other element which has the same index. Remember that part. So for that reason, I do not need to include that in my this set. Okay, so for that obvious reason, I am not doing that basically. Okay, that doesn't make sense for me to do that. Okay, as simple as that. For that reason, I'm not doing it. And finally, I'm just returning the score. Let me just quickly run this and show it to you. So see, this is how it will basically look after the sorting. Okay, if you can see here, for example, let me show you the case of two. If you can see here, both the twos are having same values, but the first value, that is the one which is present before the other one, is the one having the smaller index. That is, this one is having index 0, this is having index 5. So in this case, if the values are same, the sorting will be based on the index. Okay, that is the beauty of Python sorting. Okay, as simple as that. And same is the case here. Basically, if you see again, there are the two number, number two basically is present two times, one with the index 0, one with the index 5. Okay, so the sorting ensures that even if the value are same, they're being sorted based on the index. Okay, simple as that. So yep, as you can see, the answers are matching. And as I mentioned, this is pretty much easy solution. Okay, I've already submitted this and got accepted. So talking about the space and time complexity basically. So if you see, we are creating another input here basically. So this will take space complexity will be O of n for this. Okay, so as you can see, this is the space complexity of n. One more thing will be, we are also maintaining a set. On the worst case, it will have all the elements. Okay, basically. But see, I've used the optimization, that is, I'm not including the current index here. Okay, I'm just including the neighboring indexes in my set. Remember that. For the reason, it will not be a case that the set has exact length of n. That is true. But yeah, on if we consider the higher limit, yeah, it will be around O of n range. Okay, around, not exactly O of n. It will be around O of n range. Okay, this big O notation itself means that it's on the upper side. We are assuming, as simple as that, right? So it will be open. This also will be open, and this also will be open. Okay, as simple as that. So because of this, the space complexity will be open. Now coming to the time complexity. See, we are using a sort. Sorting will be of n elements. So n elements are being sorted. For that reason, it will be n log n times. Okay, and if you see this part again, this thing is going to take O of n time. So it is basically O of n plus n log n. But since n log n is having is bigger than n, so it will be basically n log n. So it's ideally like this. Okay, n plus n log n, because see, this is going to take O of n time, and yeah, it's going to take O of n time, and yeah, this will take n log n time. Okay, as simple as that. And one more thing that you have to think of is like this. You see, in this I am also adding some values. Okay, but yeah, remember, this is hashing. Okay, this is just hashing, and this is not the this is basically hashing is happening, right? And the hashing is basically of the same length. Okay, the number that we're adding, okay, just the indexes. Okay, so for that reason, it will take off one time. Okay, I'm not considering this part in my time consider, because I am assuming that it will take off one time as well, because the numbers are pretty small here, indexes are pretty small here. And yeah, for that reason, I'm not including this in my time complexity, as simple as that. So yep, that is how it will look like. And since n log n is bigger than n, you can simply escape that. It will be around n log n only. Okay, as simple as that. So this was the first solution. The second solution we are going to do is using a different data structure, which is going to be heap. So heap, I guess you will now be very thorough with that, because from the last few days we are using heap. And the exact same thing what we'll do is, instead of sort, we are just going to heapify the input. Okay, if you see here, this is going to be the heap solution. One important thing that will come to your mind before, which should come to your mind before using heap, is that I will come to that. But see here, exactly everything remains the same here. This is the only part which is changing. Okay, heap.heapify you are doing. And then yeah, then till the input is empty, we'll have to keep popping the elements. Okay, let me show the whole solution first. Till the This is also somewhat which is changing. Okay, in the previous, what we're doing, we are simply passing the input, but here what we are doing is, till the input is not empty, we have to keep doing this. Okay, this loop will run for O of n times. Okay, in that, if you see, we are popping each element one by one. Each popping will take log n time basically. And if it is not marked, okay, if a popped index is not marked, only then this was particular calculations will be done. Okay, as simple as that. So if you see the time complexity for this, okay, time complexity device, yeah, this will take off and time. This will take off and time, and each iteration of this is going to take log n time. So idea here is, see, each element will be popped. Okay, that is the basic idea. Okay, each element will be popped. There are n elements, so it will be n log n time. So again, it's coming. The higher limit is going to be n log n time again. You may say like, yeah, this also is going to take O of n time in terms of time complexity. Yep, this is also going to take O of n time. Okay, this CPY is also going to open time. So yeah, on a higher limit, if you see, the dominating factor will be n log n. So that's why I'm writing only n log n here. Okay, simple as that. If you talk about space complexity, the exact same thing what we saw in the previous solution. We are maintaining a set, at the same time we are maintaining input. Okay, so this input particular array we are also maintaining with the n elements. So yep, both of them will also be taking around O of n time on the higher limit. So yeah, that also will come down to the space complexity. So both the solutions are similar. But one thing that I want you to know before using this is that, see, I'm damn sure that if you use heap, the first question, okay, the first question that you will get from a experienced interviewer is that, can you tell me whether heap will maintain this property or not? Okay, this particular property. If two values are same, can you quickly show me how and why will heap return the value which is having the smallest index first, and how you're ensuring that? This will be the first question that you will witness if you're using this particular data structure heap. Okay, so for this, I'm already writing the solution here. See, the idea here is, if you see, you have to understand how heap works. Heap is a tree basically. Okay, so it depends on the order in which the elements are being inserted. First thing is that. Okay, so if you see here, I'm just printing input array, and then I'm calling the heap function. Heap function, what it will do in an optimal way, it will be inserting the elements starting from 0 to the last element. Okay, simple as that. So same thing here. the idea here is the number which is occurring first, okay, that will be inserted first. So the idea here is the number which has the smallest index will be inserted first, then a number with the same value but a bigger index will be inserted later on. So the idea here is if two numbers have the same value, then the one inserted first in the heap will be popped first. But since the one which is inserted first is having the smaller index, so this will ensure that we are popping the value which is smaller, okay, that's which is having smaller index. In case of both the numbers being same, the number which is having the smaller index will be popped first, okay, and that is what we need in this question, okay. So this thing we'll have to justify basically. Otherwise, if we are using this data structure without knowing this, first of all, this is first of all not the right thing, right? Without knowing if this will be popped first or not, it's not the right thing to use the data structure. And if you are using it, you should be confident that yeah, this case will be handled by heap perfectly, okay. That is the basic idea. So some people, what they will do is, instead of like taking the input array and then doing the heapify, what they will do is they will start, that is, instead of using heapify, they will use the heap push, okay. Instead of using heapify, they will do the heap push, so that they will ensure that yeah, the element having the smallest index is inserted first, okay. That way they are doing it. But yeah, if you are able to justify that, yeah, even if you is going to do the same thing in a smaller time complexity, that is also good. Because you would insert each element, okay, it will take n log n time, remember that, n for all the elements and log n for inserting the elements. But if you use the heapify function, it will take O of n time. But obviously it will this time complexity, this space complexity will be hard also, it. So I have already explained the space and time of the solution. I also explained this particular part, which I'm sure will be the question if you're using heap and the interviewer is an experienced interviewer, okay. Remember that they will definitely ask this point, because in this question there are not much ways to do the same, okay. There are only 2 or 3 ways. So if you're using a heap, I'm damn sure that this question will come to you. So be prepared for this kind of scenarios. So yeah, and that was all for this particular video. And I felt this question was slightly on the easier side, but yeah, the constraints are pretty much the same as that of the any normal lead code question. So if you like my video, if you like my efforts, if you learn anything from this video, basically, please subscribe to the channel. This really gives a lot of motivation to continue further. And yeah, that was all for this video. See you tomorrow. Thanks a lot.